Okay, welcome to this 8th video in a series of videos on factoring. This video assumes that you've seen the overview of factoring video, as well as all the videos that demonstrate all the techniques listed in these green boxes in this flow chart here. Okay, so this video is going to assume that you're pretty solid at factoring when given a problem, regardless of the form. Okay, this video is going to take a look at some applications of factoring. Okay, so that means we're going to talk about why we factor. Quick overview, 2 reasons why we factor, just things that happen quite often in mathematics is we will factor to simplify an expression, and sometimes we will factor to solve an equation. 2 very different uses for factoring, but they both involve factoring nonetheless. This video is going to focus on using factoring to simplify expressions, particularly something called a rational expression. So let's drill down into this concept map and develop it a little bit more. So if we're going to factor to simplify, our prerequisite skills are in fact to be able to factor, and that should be somewhat obvious. Okay? And the next one is to be able to simplify fractions, because a rational expression is something that resembles a fraction for the most part. So our fraction rules come into play here. Okay? As the video develops, hopefully we will take a look at listing out some steps. So let's move over to some prefabbed materials I have here with regard to simplifying rational expressions. The steps here, if you notice, are pretty straightforward. Step 1 is to factor, and this is to factor anywhere possible in the numerator or denominator, or both. Okay, and then step 2 is to simplify using our fraction rules. Okay, well, this seems decently straightforward, but you have to remember from our green boxes here when I talk about factoring is that there are, in fact, many methods for factoring. We actually looked at 6 of them. So there's a lot of choices here when we go to factor. There's a lot of different methods we have to apply. Okay, so you have to realize that there's 6 methods that you should know. And the most important of these to be able to start out with, I can't highlight this enough, is always starting with GCF if possible. Okay? So let's take a look at our sample problems here. So in problem A, it says negative 6x cubed minus 2x squared y, all divided by the quantity 12x squared plus 4xy. Okay, now the big mistake that people make is trying to say, well, this has 2 terms and this has 2 terms, so I'll just match up the first 2 and match up the second 2 and try and treat them like fractions. This is completely wrong. Okay? You have to take the entire numerator and treat it as an expression and treat the entire denominator as an expression. That's because they're in fact both quantities. Okay? You can't do the division until you've addressed the quantities. Well, you notice I can't really simplify the numerator or the denominator. So what I'm going to do first is factor it. Okay? So I'm going to put GCF at the front of my mind and say, well, there's negative 6x cubed and 2x squared y. Do they have a GCF? And the answer is, in fact, yes. The GCF, if you look at it, is going to be negative 2x squared. Okay? So I'm going to then factor that out of the top expression and then divide both terms in the top expression by negative 2x squared. And that's going to give me 3x plus y. Okay? So the numerator is just re-expressed as a product, which means I've factored it. Then I'm going to look at my bottom expression and say, well, gee, is there a GCF for 12x squared and 4xy? And there is. And that is going to be 4x. So then I'll divide both terms of the denominator by 4x. And then I'm going to get 3x plus y. Well, that's very convenient, because now as I move to step 2, where it says simplify, I actually can just simplify using what I know about fractions. Well, anything over itself is 1, so that cancels. And then I've got this portion here of negative 2x squared over 4x. So that is going to give me negative 1/2 x. Just a quick review of that. I needed to subtract the exponents when I did the division, and I just simplified the fraction of negative 2/4. Okay, so the answer to this big honkin' thing to start with is just that it's equivalent to negative 1/2 x. And again, I factored the numerator, factored the denominator, and simplified using good old-fashioned fraction rules. Okay? Fraction rules also thought to be division rules where the exponent was involved. I had to realize that rule was subtract my exponents. Okay, so now in example B, which is the quantity m squared minus 6m plus 8 divided by the quantity m squared minus m minus 2, I need to be able to simplify that. Well, again, the big mistake that kids make is trying to go cancel the m squareds. Well, you can't do that. It's just not right. You're breaking the order of operations when you do that. Similarly, you can't say, well, 2 goes into 8 4 times. This is also not legit. So if we just try and get into this mindset, it's a mindset that you have to create when you look at these rational expressions. It's factor and simplify. Well, if I look on top, there is no greatest common factor. Okay? Then I think of my other methods. Well, it's obviously not a difference of 2 squares because it's 3 terms. It's obviously not a perfect square trinomial because it ends in 8. So I think it's an easy quadratic trinomial. So my method for that is just to find out what the factors of 8 that add up to negative 6. Okay, and you should be decently quick at that. And you should see that you get 2 sets of parentheses, m and m, and the factors of 8, whose sum is negative 6. I think 2 and 4 will work as long as I just make both of them negative. So that's going to give me minus 2 here and minus 4 here. Then continuing on, I got to factor and look at the bottom. Well, again, always looking at GCF first. I don't see a GCF. It's not a difference of squares. 2 is not a square, so it's not a perfect square trinomial. And then I guess I'm going to think, it's an easy quadratic trinomial. So I think, what are the factors of negative 2 that add up to negative 1? Well, the factors of negative 2 that add up to negative 1, I guess will be 1 and 2 as long as I make the 2 negative. Okay? So that's going to give me m plus 1 times the quantity m minus 2. Well, then I'm going to look to simplify this expression, and I just see that I can cancel my m minus 2 and my m minus 2, because when I divide them, I in fact get 1. Well, this means that the remaining expression is the quantity m minus 4 divided by the quantity m plus 1. Okay? I hope you're seeing so far that you have to be able to factor well and quickly, because now factoring is just a step in a larger process. So our ability to do this well and quickly is of a premium. Again, you're going to be continuing to practice your factoring skills here because you're putting them to use. So in our third example, where it says C, where we have the quantity x squared minus 25 over the quantity x squared plus 10x plus 25, we try and notice if the numerator or denominator has a common factor. And I don't, in fact, see one. So as I took a look at just trying to factor the numerator, I see that it is a difference of 2 squares, which is just a special pattern, which is quite easy, of knowing that it can be factored into the product of the sum of the square roots and the difference of the square roots. So the square roots of x squared are x and x. 25, it's 5 and negative 5. So continuing on to the bottom, I see that it does not have a greatest common factor. It's not a difference of squares, but I do in fact notice that it might be a perfect square trinomial because the square roots of x squared and 25 are 5x, 5 and x. their product is 5x. When I double that, I get 10x, so this is a perfect square trinomial, which means I'm going to get two binomials that are identical, and that's just going to give me the sum of the square roots twice. I know it's the sum of the square roots because the middle term is positive. Again, whatever you get for that middle term, both the signs are going to be. Okay, now I go to simplify again, and I just noticed that my x plus 5 can cancel my x plus 5. That is the one that's on top can cancel the one on bottom. And that is going to give me a final answer of x minus 5, that quantity divided by x plus 5. Okay? So if we notice here, I tend to think that the quantity I started with compared to the quantity I finish with is definitely something that looks a little simpler. Okay? Especially in this first problem where I got this kind of difficult looking fraction, and then I ended on just something that's negative 1/2 x. Okay? So again, the steps that we want to reiterate here are that we factor and we simplify. Okay? And I'm going to take a quick screenshot of them and add them over to our concept map, and then we will in fact be done with that. So again, the steps are to factor and simplify, and they are just to be repeated over and over and over as best you can until you master it. Okay? So I hope that is a decent enough explanation of how we're using factoring to simplify expressions. Not long from now, you will be looking at how to use factoring to solve equations. So, again, I can't reiterate enough, being skilled in these 6 methods of factoring become very important. The examples I did only involved the first 4. That does not mean you won't find examples or be asked to practice examples that involve the last 2. Okay? So enjoy, watch again, 10-year practice problems, and become a master.